In-course corrections. A hypothetical situation on making in-course corrections for activities, assessments, and learner engagement. Thinking like a scientist. The course I have created is one in which students will explore how scientists investigate the real world, identify the skills and attitudes of a scientist, and be able to form scientific questions and hypotheses following the scientific method. The target audience comprises of grade 7 middle school students between the ages of 12 and 13 of mixed gender learning in a hybrid environment. Having completed elementary and grade 6 science curricula, students have been exposed to scientific inquiry and expected to have previous knowledge of the scientific method. A mix of different learning styles is expected, with majority being tactile and visual learners. The learning objectives are geared at exposing students to a mix of interactions, including discussion boards, videos, collaborative exercises, creating digital media and role play, while observing and making conclusions about the skills and attitudes of scientists. In collaborative groups, students will express their views on what makes a scientist and share in the creation of knowledge. The first activity sees students observing images of scientists at work. Probing questions are asked, and in groups with breakout rooms online, students will answer the questions posed using Google Slides. By using slides, the instructor can observe the participation of students as the names are visible, and students participating are able to share and edit the slides in order to collectively contribute to the assignments. Small groups allow for different levels of knowledge to be shared with the support of other learners. Observations are useful for collecting qualitative data and records what students are not doing. Having discussed as a group how the scientists work, students will make individual contributions on a Padlet wall. By using this interface, another level of interactivity is added, which provides a place for information exchange and knowledge sharing, and highlights different perspectives. The instructor will also at this point be able to provide feedback and praise students who ask questions. Again, observations will be noted of student participation. By this point, several observations have been made. Majority of students have been actively contributing to group discussions and made significant contributions to the group slides and talking points in the breakout rooms. Google Slides with the views on scientists were completed for all groups, and those with minimum contributions gave one-liners on the Padlet wall without much elaboration. The third engagement was for individual thoughts to be expressed. Students were given an exercise to film a short-minute video on the roles of scientists and whether or not they considered themselves scientists and why. Students had the option to show their faces, use creative filters, emojis, and stickers, or remain unidentified. Posts were moderated in order to maintain privacy of students, but only when asked were some videos shared with the class. The trends observed were such: 11 out of 21 students showed their faces, 7 students used emojis and other creative features to hide their faces, and 3 students did not create a video, but 2 sent a text response, leaving 1 student without a submission. Comments were made in the student page on the LMS, noting their failure to submit the assignment. Following the interactive video creation, students were once again placed in groups to research and formulate a digital word wall on all the terms related to scientific thinking. Students had to then define each term, and in a format of their choice, were given the task of creating a digital picture book illustrating the definitions. In this learning engagement, the Pictionary, or digital dictionary, was a collaborative effort, and students could use any graphical representation in a platform of their choice to present their group vocabulary. They were able to use the internet to search or their textbook to find the definitions, and evaluated each other's contribution using peer evaluation rubrics, in addition to the rubrics for assessing the Pictionary. This qualitative data was used to assess student participation and gauge student activity. Chickering and Gamson defined 7 principles for effective teaching and learning. Having reached this point in the course, all principles have been employed, but of great importance is initial contact that has been made with the instructor and learners, and there was cooperation among students. Feedback was given to learners in the wider class setting, but having observed the lack of participation in a few students, emails were sent regarding their missing assignments with a timeline given for submission. Jane Goodall, considered to be the world's most significant expert on chimpanzees, with a 60-year study of family interactions of wild chimpanzees, was observed by students. Students would then brainstorm using Google Jamboard ideas of what attitudes or qualities scientists should possess and the qualities that Jane shows. They were expected to identify at least 5 qualities and after discussing in groups, posted their ideas. The groups then had an opportunity for role play. Having identified 5 attitudes of a scientist from the previous engagement, they could act out these characteristics, showing how they play out in their daily lives. Through cooperative learning, they had a chance to engage another intelligence from Howard Gardner and apply higher order thinking. It was observed that 19 students actively participated in this activity, with 2 non-participating students. As an official formative assessment, there are 2 tasks that were assigned. Having been given multiple engagements to employ active learning techniques as recommended by Chickering and Gamson, students were given a performance task to be assessed using a rubric. In groups of 2 to 3, students created either a brochure or a poster to portray the attitudes and qualities of a scientist, the skills involved, and how these skills are portrayed in their daily lives. A rubric was used to assess content, organization and layout, research and collaboration, and creativity. Again, peer evaluation was used to assess individual contributions to the group, and a short multiple-choice quiz was administered for individual assessment. Both assessments were used as quantitative data collection methods to analyze student understanding, participation, and progress. Having analyzed the results from the performance task and quiz, it was evident that 2 students were falling behind, even after being encouraged to reach out for help. In order to receive additional help, students were invited to visit study hall after school, where the teacher was able to engage and find out where they were having trouble, what questions they needed clarified, and go through their answers on the quiz. The students were scheduled at separate times in order to allow confidentiality and give each student individual attention. From the conversation, students explained where they had difficulty, particularly in understanding questions being asked, and having a lack of focus in some activities made them unable to find information needed to complete each task. From the engagements and interactions in the course so far, as well as from conversations and evaluation of scores, it is evident that the following principles from Chickering and Gamson were used to ensure quality teaching and learning. Seeing that all these principles were employed, there were few ways in which in-course corrections could be applied, particularly through increasing contact between students and instructors and giving more personalized feedback to struggling students. Having checked in with the struggling students, the following in-course corrections would be made. More frequent check-ins with students with scheduled follow-up meetings, creating checklists for the failing students to hold them accountable for submitting work according to deadlines. Directions and guidelines would be broken down into simpler terms and rephrased to ensure student understanding and clarification. Additional tech support would be given for students who may have difficulty creating digital media. And to improve course navigation, students would be asked if they had difficulty accessing information and where to look. And in doing so, navigation would be made more clear by ensuring that all resources are readily accessible. In considering the ethical and safety implications of data collection, 2 important factors are considered. These are privacy and the use of student data according to FERPA, Family Educational Rights and Privacy Act, and means of developing trust in online environments. When using online collaborative platforms, students should always be reminded to keep their passwords and personal information safe. Within the course material, statements will be made that confirms that the student consents to the use of their information being used. Tracking software may be malicious, so it is best to keep activities within educational platforms. Websites should be checked prior to assigning tasks in order to ensure that students will not be taken to unfriendly websites, and encourage students to disable tracking in apps. Additionally, all student information, statistics from test analysis, and information about student progress should be kept confidential. In order to build trust, privacy policies should be clearly stated and transparent to enhance credibility. Security measures should be included in the design of the course and the software and platforms chosen, and fostering trust in the relationships between learners and instructors should be actively protected with assurance of privacy and access to learning environments following established security standards. In conclusion, it is important to apply Chickering and Gamson's 7 principles of effective teaching and learning to ensure maximum engagement and achievement of students. Qualitative data in the form of observations can be used to inform student participation, and quantitative data gathered from grading projects and tests assess individual performance and student progress. By identifying and following up closely with students falling behind, it is easy to quickly make in-course assessments and corrections to improve student engagement. By factoring how directions and guidelines are outlined, offering technical support if necessary, creating personalized checklists for student accountability, and improving course navigation to enhance student success. It is also highly important to consider student privacy and safety in the online learning environment by following ethical considerations to ensure privacy and build trust.